You have to readjust it maybe. Okay. All right. Good. Here's the missing page. Missing page from the packet. I have quiz 3 here for you. We're still talking about these variables, and let me just pose a question to you really quick from what we've said so far. So if you have a welding procedure that's done, it's been established, we've gone through all that process, and then a welder comes along, and is it possible for that welder to weld under that procedure with some of those variables being changed? And that's kind of a leading question. So you're shaking your head yes. What do you think, Tyler?
What was the question again?
You have a procedure, an established procedure. It's been tested, there's a PQR, there's a test record. And then you're testing welders, or you're out on a job somewhere as an inspector or a quality manager or a welding engineer. And the welders are using something different to weld this material with this filler material. And they're qualified, they're supposedly qualified welders. Can there be a welder welding with things that are not exactly the same as the procedure? That's the question. This is a question about essential variables.
No.
Think about it for a minute.
Which variable?
Pick one.
What's the pertinence of
Pick
it?
one. I talked to you about these. I talked to you about pipe grades. I talked to you about preheat. I talked to you about travel speed. Can some of those things be slightly different and still be within the procedure? Sure, they can. You have to know those specific things. Like we talked about this a little bit. So if the procedure calls out a rod from group 1, and it says specifically A5.5, and the procedure was welded with 70-10, can there be a different rod used? You use 70-11. There's one other rod that you can use. You see what I'm saying? Okay. You will find sometimes on procedures down in the comments section or somewhere else on that, or even on the PQR. You have to look at the PQR sometimes. For example, a couple of years ago down in Salt Lake City, we were rerouting some pipe where the Mountain View corridor was going through. We had to dig that stuff up and dig it out of the ground so they could put the highway there, but before we could do that, we had to reroute the line out around it. And the procedure that we had called out for, 60-10. Called out for 60-10, let's see. Yeah, called out for 60-10, 5P. But the contractor was insisting on using 60-10, 6P. And normally that would be within the group, wouldn't it? Because it's still 60-10. What's the difference between 5P and 6P? Do you might know? Is there anything additional? Are there other rod groupings in that 60-10 group? Yeah, there's 5P, 6P, 7P, 8P, 9P. What's the difference?
Cellulose content?
Nope. It's mostly iron content. They add a little iron in the coating, and what that does is, as that number goes up, the elongation increases. So in this particular case, it was a good thing because this was hard pipe, they needed more elongation in the root, so they increased it to 6P. Is that a violation of the procedure? On the surface, no, it's not. But if you look on the PQR down in the notes section, the engineer had included this one little line: absolutely no rod substitutions. Can you see the battle that ensued? Who wins? The engineer. Because the engineer said absolutely no rod substitution. He came out to the job site and said, "What's the issue? What's the problem?" I said, "Well, the problem is they want to use 60-10, 6P, and in our procedure we've used 5P." And he says, "What's wrong with that? We're in the same group." An engineer that didn't know the difference between those rods. Plus, he had written on that PQR, the qualifying document for the WPS, absolutely no rod substitution. In this particular case, you couldn't change it because you had to ask for a meeting with the DOT, and then that took 2 weeks, and then the DOT took it under advisement for 2 weeks, and then they would render a decision within 2 weeks. So you're talking about a month and a half is going to go by just simply to change that one rod from 5P to 6P. It was a good move, it was a good call, but you couldn't do it. So I want you to be aware that when you're looking at these WPSs and the subsequent PQRs that go along with it, quite often you have to kind of part between the fine hairs of that thing. The contractor was wanting to do something that was good, and I could have let him do it, and in my heart, in my objective look at it, that would have been a good move. But I had a procedure that said I couldn't. So if the engineer wanted to write me an email that said it was approved by him to switch from 5P to 6P, we could have gone ahead and done that. But because it was a DOT and a PHMSA regulated line, you couldn't change a jot or a tittle on that thing without their approval. Okay, so we welded it with 5P and everything was fine and we moved along. But under advisement, I told the engineer, you really need to go through these procedures and fix some of these things, because that's the way it goes. Okay, so I want you to know about that.
So under that procedure, he could have just in the comments said, absolutely no changing of the filler rod outside of its groove or something, and it would have fixed that problem.
And they did. But it literally took 2 years. Because this particular company is operating under a special permit to operate at abnormally high pressures continuously. They have a special DOT permit to run 1,333 PSI maximum, which is killer stupid high for natural gas. But they have to have it in some places because of the distances between their compressor stations. So by the time it leaves one compressor station at 1,300 PSI, and it travels the 100 miles or 150 miles to the next compressor station, by the time that gas gets to the compressor station, it's down to 800 PSI. So if they don't have it up high enough here, it's not going to be high enough here when it goes into the plant to overcome the appliances that it has to go through in order to be repressurized back up to 1,300 to be pushed to the next compressor station. So it's like big bubbles that are pushing through that. And they start off high pressure and then they gradually get less and less. Okay. Which comes into play when doing hot taps, but we won't get to that. Okay, so we've looked at the filler melody. You'll see I wanted to mention one other thing. Is there a difference between a welding procedure qualification and a welder qualification? You know the difference of that? Okay. And then if a qualified welder using that procedure goes out on a job site somewhere and uses something slightly different, is the welder still qualified? And could you give an adequate answer for that explanation? Yeah, he can. If the preheat in the procedure says 250 degrees plus or minus 50 degrees, what does that mean to him? 200 degrees. Yeah, and 200 degrees has to be when he strikes the arc. So a lot of these times they'll say, well, the procedure says 250 plus or minus 50. So as soon as they're heating that thing up, and as soon as they get a 200 reading on a temperature crayon over the gun, they'll shut down that preheat operation, and they'll go over and they'll make a tamale, and they'll eat a couple bites of the tamale and have a cup of coffee, and then they'll go back and they'll start welding. And you'll say, whoa, 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 wait a minute. You're supposed to preheat that. And he said, I did preheat it. But it's not 200 anymore, because you walked away and you ate a tamale and you came back, and it's probably now down to 150. Well, I preheated it to 200. What is the reason you preheat? You preheat so that when that arc welding is being done, the heat from that weld isn't sucked out of the weld. You got to have a minimum of 200 degrees. He's got to be standing there ready to strike the arc. When that temperature is pulled off, then he can start welding. All right. Then you have to maintain an inner pass of so much and an inner pass maximum of so much. You have to stay within that range. Why? Because of metallurgical reasons. Just a quick story. I did a pipeline up here in north of Evanston, 16-inch pipeline, and I told him it's a 300 degree, 275 degree minimum preheat. This was hard pipe, it was X70. So, I had them set up, a couple guys with rosebuds right in front, and they bring the pipe, they put the internal clamping machine in there, they get it clamped, they get ready to go, and they have to heat that up. To get it heated up to 275 degrees, then the heat up guys move to the next section, and then the welders can put the bead pass in, the first pass. Okay? You have to have 100% of that before you can move that clamping device. So everything looked like it was working right. I was watching. They made several joints, 10 joints, 12 joints, something like that. Everything was moving along really fine. And then I went to the back of the line, because I had guys back there making repairs. I went back there to check on the repairs, a couple miles back. Got in my truck, drove back up there, and what do I see? I see 3 or 4 sets of guys with propane burners up the pipeline, with pipe has been laid out on skids, and they're up there preheating the pipe. 3 or 4 joints ahead. And so I called the pipe boss. I was like, what are those guys doing? Well, they're preheating the pipe. For what? It still has to be preheated before you make the weld. No. Procedure says to preheat to 275, so we're preheating all that pipe, so we can just go ahead and weld. You're slowing us down with this preheat. No. Okay. But a welder could go on there, and if your procedure says, 300 degree preheat Fahrenheit, plus or minus 20 degrees, plus or minus 50 degrees, he could adjust that down to 250, as long as it's 250 when he starts welding. Okay, so I think I got all the questions on quiz 3 kind of covered. So you should be able to think about those questions and write them down. There's a couple of them that are just yes or no, and then you have to answer further on. Okay, I want to take a look just a little bit more at some of these essential variable things. So we covered that, we looked at that. There's post-weld heat treat. If there's any addition of a post-weld heat treat or a change from the ranges or values, that constitutes an essential variable. You can't change that post-weld heat treat without a change in the procedure. That's a very common problem. Okay, all right, now, the welding of the test joints for butt welds, To weld the test joint for butt welds, 2 pipe nipples shall be joined. That is a appropriate name. Okay? Nipple is a really appropriate term. Shall be joined following all the details of the welding procedure specification. Okay? So if you got an argument with some pipe boss or somewhere like that, you just refer to that. 5.5 says you will weld it according to the welding procedure specification. So welding it, preparation. Here's the preparation, and it says that the test specimens shall be cut to the joint location shown in figure 3, and the number of test specimens and tests to which are subjected are given in table 2. So let's take a look at that. There is the figure for pipe coupons. What do you see specifically about those diagrams that catches your eye? Just look at it for a second. Look at the sizes. Do you see that the sizes correspond to the size groups that you can put a welding procedure specification into? Okay, so if you're dealing with something between 2 inch and 6 inch, this is for under 2 inch, so less than 2 inch. And quite often the entire coupon becomes a test coupon if it's small enough. But we usually don't do much smaller than 2. Here's some more parameters for number of specimens that can be taken and where they're to be located. This is for greater than 4 inch. Notice the diameter size there. That's 4 inches inside, so that's 4 inch pipe. It's 4.5 outside. Okay, but less than or equal to 750. I run into a lot of problems with this because I get on a job and I take a physical measurement of the 12-inch pipe and it's way bigger than 12.75. It's 12.9. Well, what do you do then? Technically speaking, it lapses you over into this size, doesn't it? Technically speaking. But if your MTR says it's 12.750, if your MTR, the document that tells you about the chemical composition and the heat number of that pipe, if it says it's 12.750, then you're dealing with 12-inch pipe. You just leave it at that. But I've run into this before a couple times because of that little theme right there. Typically, you're talking about the 3 pipe size groupings: 2 inch, 12 inch or less, and greater than 12 inch. So it's the same 3 pipe sizes. Okay. Now notice there's a little difference here. I didn't pull this all the way down because this is for what? So for a procedure qualification test, there's a different set of coupons than there is for a welder qualification. So if you're testing a procedure, there are different sets of coupons that you have to pull. Okay? And if you go way down to here, notice that this is for welder qualification test. This is a common mistake that happens all the time. You're testing welders and you'll find an inspector that's making them pull 4 straps. And notice that for 12-inch pipe, you're only pulling 2 faces, 2 roots, and 4 nicks. Now notice it says nick and tensile, but and we'll look at that. But if you read down in the documentation, it says at the company's decision, you can substitute the tensils for nick breaks. And most everybody does nick breaks. Why? Because they're simple, doesn't require a trip to the lab, doesn't require more fees. Now I happen to have a portable high pressure tensile tester. So if we choose to do tensils, I can do it. But notice there's a difference between the test coupons pulled for a welder qualification, which is figure 12, and we go all the way back up here to figure 2, and here figure 3 shows the same thing here but there's more here. So is there a difference between the coupons and the straps and the numbers for welder qualification and for procedure qualification? Yes, there is a slight difference. Okay. All right. And I just got called on this yesterday. I had an urgent phone call when I walked out of the building yesterday from a company that I tested welders this last summer for. And they said, hey, did these welders, did you guys do nick breaks on their branch tests? Yes, I did. It's not on your procedure. It's not on your WQR. Oh, really? I'll have to take a look and see. That welder qualification though, it says right at the top for butt and branch. And I qualified it and signed it. Yeah, but the inspector down in Mesquite is saying he doesn't see the branch breaks on there. Well, if they didn't pass, you wouldn't have the document. But I'll look. I just happen to have them right here for you. So here's a welder qualification record for API 1104. This happens to be, I just noticed another mistake. This is his appendix B. That's the wrong one. Okay, this is his button branch. So this is for API. API appendix B we'll get into later. Notice there's his number. So he's born in November on the 8th day. Okay. So we look down here a little bit further. Pipe butt weld test, X52 to X52. There's the size, there's the wall thickness, there's the joint design. You can see those corresponding values that we've been looking at on the welding procedure. Okay. All right, and then down here it says right here, butt and branch. So if I click that, if I put an X in there and I sign it down at the bottom, like I do, qualified welding inspector witnessing the test, that's me, then they've passed. But what he was saying was, when you look at this chart right here, I had what did I have there? I had N1, N2, N3, N4. Because you have to pull 4 nicks. 2 nicks and 2 tensils, or 4 nicks, at the company's discretion. So I had these in here. I had N1, N2, N3, N4, but I did not have these in here. Branch 1, branch 2, branch 3, branch 4. So for a butt and a branch, you can see now I have 2 faces, 2 roots, 4 nicks for the butt weld, and I changed that to BT. And then I put these 4 in here, BR, for acceptable. And typically in most of the stuff that I do for people, if I click that thing that says button branch and I sign off on it, that's it. It's redundant to put that there. But some people want to see that there. So I had to fix those, send them to the engineer. They had to be signed off by the company main engineer and then sent back to Mesquite, because there was an inspector there that was rejecting the WQRs because they didn't have the branch nicks. So welcome to my world. So that was one that was done July 28th. Okay? All right, back to this one. So now you can see these 4 on the procedure qualification test, and then if you go back down to the welder qualification, you'll see the same thing here, right there. Now I only have 3. See that? For the welder qualification test, you have 4 tensils, 4 nicks, a face or a side bend, a root or a side bend, a face or a side bend, a root or a side bend. So basically 2 roots and 2 faces. 2 roots, 2 faces, 4, basically you have 4 nicks and 4 tensils. Notice here under note 1, at the company's option, the locations may be rotated provided they are equally spaced around the pipe. However, specimens do not include the longitudinal weld. And that's why you get that rotation rule in there, because sometimes welders will turn the pipe So you have a piece of the seam weld here and a piece of the seam weld here. You're not ever supposed to put them in line, but you can put them in line on a welder qualification test because of this rule. Because sometimes those longitudinal seams get in the way of you making your cut straps, to cut your straps out. So what they're saying is you gotta position them so that you don't end up using a longitudinal weld in your testing. Nowadays they're much stronger, but when this was written, we had a lot of problems with seam welds bursting, ripping open. So now they're much stronger. Okay, questions on that at all? Did I go too fast? Okay, just zipping right along here then, we're gonna look at a couple more things. Here is the table, this is table 2. This is the table and number of test specimens for the procedure qualification test. So if you're doing a test where you're qualifying a procedure, this is the chart that you use. So most people use this right here, 12-inch pipe, this is 12-inch pipe. Why would you use 12-inch pipe?
Because it qualified for you for everything that you need.
It's correct. If you do 12-inch pipe, you're qualified for all pipe sizes, all wall thicknesses, depending on what position you do it in, but everybody does an API test in the 6G, which is the hardest one. And for a welder, 6G is the easier. 5G is the hard one. Because with 6G, you're kind of doing a horizontal. If you've welded enough, you understand it. But for, you find the outside diameter, this is just in millimeters, 4 tensils, 4 nicks, 4 roots, 4 faces, just like we saw in the diagram. Okay? For a total of 16. Right? This top section is for wall thickness less than or equal to 500 wall, half-inch wall. Greater than 5-inch wall, notice the difference in the number of straps that you pull. For 12-inch pipe, you pull 4 tensils and 4 nicks and 8 sides. That's usually because people don't have a bender that's strong enough to bend face and root bends for half-inch. I, however, I do. I have one that can bend them. Okay. You always want to pay attention to these little footnotes, like right here, that's footnote B, there's a footnote A. Footnote A for less than 2-inch, you have a total of 4 straps. Footnote A says 1 nick break and 1 root bend specimen are taken from each of 2 test wells, or for pipe less than or equal to 1-inch pipe in diameter, 1 full section tensile strength test specimen is taken. What does that mean? If it's small enough that you can't get your test coupons out of it, you might have to do 2 tests to get the adequate number of straps. Okay. Footnote B, for materials with smice greater than, what's a smice?
Specific material.
Specified manufacturer's yield stream. It comes from the manufacturer with a specified yield. And what is yield?
Where it starts to stretch.
Where it stretches and won't stretch back. Greater than the material specified as API 5L grade X42, a minimum of 1 tensile test is required. For materials greater than X42, a minimum of 1 tensile test is required. Notice it says 0 here for less than 2-inch and 2-inch to 4-inch. If it's a smice greater than, if it's X60 or X65, 1 tensile is required. Okay. Okay. Covered all that important stuff. These are tension test specimens. And I think, has everybody done one of these? Been involved with making these before?
Dog bone?
Nathan, you ever done any of these? Made any of them? Huh? Dog bones? Oh, okay. Can you do them? Can you do them like this? Do they have to be prepared? What is a tensile test the test of? Huh? You sound like Cartman. I mean, you sound like that guy in South Park.
No, tensile strength.
Tensile strength, yes. Okay, and tensile strength is simply cross section by the amount of pull, right? And it has to be a minimum value. So why do they dog bone them down like this?
Because you don't have a machine that can pull it full size.
Yeah. So I asked the question again, can you do them in bigger pieces? Yeah, of course you can. And you'll find welders that they'll throw the tensile coupons on your table, and you'll say, hey, you need to nick these down. Well, an experienced inspector will say, well, okay. I mean, in some cases they're hurting themselves, but anybody in here worked with like professional welders? They're kind of arrogant, most of them. Okay, and they're there to show the world that they're the best, usually. And I at least tell them, well, take it back at least. Go back at least, and along this edge right here, radius those down, for heaven's sakes. Because if you have a sharp edge like that, where they've cut the strap like this, and you've got that square edge, that can create stress risers. And if they don't want to radius those down, that's fine with me. But what happens is you have this edge like this and this edge like this. It's a nice square edge where they've cut it. If you turn it sideways and look at it this way, when you start pulling on it, they go like this. Those stress risers will open up cracks and they'll yield at a lower amount of tensile. So yeah, if you want me to pull them that way, if you got a tensile tester big enough to do it, yeah, I do. And you can pull them. And if it breaks in the weld, is it disqualified? Not necessarily. That weld has to yield at 1.3 higher than the tensile. So, this is where your objectivity, subjectivity, your own conscience comes in. Can you live with yourself, sort of a thing. If they insist on doing it this way, that's fine. And quite often they'll be just fine. They'll pass, And every once in a while you'll have one that'll break. Oh, you pulled it too quick. I don't have any fast or slow. It just goes this speed. If you want to prepare another one, I'll let you push the button. See if you can slow it down or speed it up. Okay, but yeah, so they want them. They normally neck them down like this, so you get a measured cross section. Because you're measuring that tensile per square inch. So if it's not 1 square inch, can you still do a tensile test? Sure, because that cross section is a fraction of 1 square inch. And that fraction of a 1 square inch will yield at a proportionate amount lower, but it will still tell you the tensile strength. Okay. So this is how they want you to do it. Notice this 9 inches, and this is probably one of the things that gets violated the most. Why do we have to have a 9-inch strap?
So you can clamp down on it.
Yeah, so you can clamp down. A lot of times these machines won't close up close enough to where you can get some little 6-inch strap. I have to take some into MSI all the time that are 6 inches or 7 inches, and we both look at each other and we kind of laugh, because it's like, I told them, and you can bust them if they're not 9 inches long. You can bust them because it says 9 inches, right? Shall be 9 inches is what it says. So if you need shorter than that, you can cut it off, but it has to be at least 9 inches long. So if you're doing a strap, we don't do this in API, but if you're doing a plate test, and it's only 3 inches wide, and they left a 1/2 inch gap in the middle, it's only 6.5 inches wide. A lot of times you take them to the testing lab, you can't even get them in the tensile puller. So what do you do then? You weld a bar onto either end. We weld bars on the either end, and, you know, the weld will be much stronger than the rest of it. So we just weld bars on either end so it has grippers so we can grab it. And it'll still test that weld. You can get around it if you have to. Depends on the kind of guy you are. If you want to just be, you know, I guess it depends on whether you like the guy too or not, whether he's pissed you off. But it says approximately 9 inches, but it has to be 9 inches minimum. Okay, these are the nick brakes. Anybody unfamiliar with nick brakes? You've done nick brakes before? Okay, this is very common in API. It's an old test. To the untrained eye, it's really kind of a hard test to determine anything from. Because mostly if they've welded it right, and they've welded it with the right heat, and they've got adequate fusion, and they've cleaned things out, then the nick brakes will be clean. But here's the problem. It shows approximately 3/4 of an inch, and then they're supposed to notch out by hacksaw. Specimen may be machine or oxygen cut, edges are smooth and parallel, but you nick this edge and you nick that edge. And if you notice this drawing, that looks like you've taken a lot of material out, right? It's not supposed to be very deep. I think it says, yeah, no. Oh, there it is. Transverse notch not to exceed 1/16 of an inch in depth. So what do you do if it's more than 1/16 of an inch? Bustable? Yeah, it is. If you make those deeper than 1/16 of an inch, what are you doing? You're removing basically some component of the test material. You have to have an adequate face there to be able to judge the internal part of the weld. That's the pro side of it. The bad side of it is the more you leave, the harder it is to break, because you're usually breaking these by hand. So you put them in a vise, and we're going to be doing some of these, so you'll get a chance to see. But you put these in a vise, and you take a 3-foot or a 4-foot long pipe wrench, and you put that pipe wrench right over that weld, and then oftentimes you have to put a 2-foot cheater on that pipe wrench, and then the best thing to do is to kind of snap them. If you can get them to snap, then they'll break. But if you try to pull on them, what happens to that nick brake coupon is it twists. The whole thing will twist. And if you've worked and worked and worked, and I tell you, the hard ones are the branch welds, because now you have this kind of a nick brake. How do you break that one? There's a trick to it. Physics will work. But I've labored for an hour trying to break a nick brake and can't get it to break, an 80-10 nick brake. And so what I'll do, or if it breaks, sometimes it'll break above the weld. So now you have this piece here, you have the weld, and you have a little stub of the coupon. So what I do is I have them put it in a vise, and then I take a torch, and then I very slowly, I will just go across that nick brake and cut that nick brake. I'll just slice through it, back and forth through it. Just let that metal roll. It'll just melt off of that nick brake. And I can tell if there's anything in it. Because if you ever cut something and there's a piece of slag or something in that material, you'll see it, right? You see a little black dot. So I cut that across there, and if I see anything in there, it's a bust. If I can wash all the way across that and go all the way through that weld and not see anything, then I pass it. That's one way I get around it. Anyway, that's what a nick brake looks like. Notice they're 9 inches long as well. We will see when we do the branch, when we look at the branch, you'll see a little bit of difference in coupon. This is the dimensioning for exposed weld surfaces and discontinuities found in nick brakes. The general rule is the depth, the length, and the distance apart. So a maximum in 250 and greater wall thicknesses, the maximum can be 1/8. The distance between them has to be at least the wall thickness. So maximum 1/8, distance between 3/8 in 250 or greater. Okay, I think we've run out of time. Grab one of these when you go. This is the week 3 quiz. And we'll take it up from there on Monday. Can you kill my stuff for you?